Okay, so now I'm going to show you guys how to do uncertainties in your measured data when you have actual data points and a fit line from those data points, but there's going to be some deviations for each data point and the fit line. They're not all going to go right through the fit line. So you need to find the fit line and then take the difference from where the data point is to where the fit line should be at that point. So I have some data from the lab that was conducted where you just simply dropped a ball and you wanted to measure the acceleration. And since there were no other forces on it except for air, there is technically a little bit of air drag, but we're neglecting that. We're really concerned about the force of gravity. So we expect the acceleration to be somewhere around 980 centimeters per second squared. So I moved over the time axis and the velocity axis, or the y velocity axis, because that's the direction that we care about in terms of velocity. So I copied and pasted them into these two sections, and I'm just going to do the standard make a scatter plot of the time versus the velocity in the y direction. So we're plotting a velocity versus time graph under constant acceleration, so we should get a linear slope or a linear graph with the slope being the acceleration. So I'm just going to go ahead and hit scatter. Okay, so the first thing that I want you guys to do for your lab reports is to get rid of this line here, the blue line, because that's not your fit line and it's just connecting the dots. So that doesn't give us anything good in terms of like scientific analysis. So probably the easiest way to do it is just right click on the blue line, go up to outline, and then just make it white. Before it worked for all of them. Apparently, you have to do each individual one. Oh, okay, there we go. So now that the line that connected the dots but isn't technically the fit line is gone, we don't want that in our lab reports. What we do want is the fit line. So click up here, make the trend line, go to more options. We want to display the equation on the chart, and there we go. So now we have our fit equation. So now what I'm going to do is I'm going to make another chart where I actually input the values of the fit equation into the Excel sheet. So we have negative 944.97 times x, and in this case our x is our t. So we're going to do the 944 as a constant and then multiply it by these cells that are in the J column, but we need to multiply that by this constant right here. So I'm just going to start over here and then say equals negative 944.97, and then we need to multiply that by J15. Okay, so we have, and then we also need to subtract 43,879. Okay, so now we have, because J15 is 0. Okay, so now, and actually the other thing that we want to do is we want to make this the absolute value. Because we're just looking at the absolute difference from the trend line to what we measured. So we need to make this the absolute value because it can be under, but that's still a positive difference between the fit line and our data points. So we'll put it down there, and then all we need to do is drag this down, and we get the quote-unquote expected values for all of our for all of that which fits that which corresponds to our fit line. So now I'm going to go over here, and what we need to do now is we need to take the absolute value again of this one minus this one. You know what? Actually, so we don't take the absolute value of this. We take the absolute value when we subtract the two. So we want the real value. we want the real value for these ones, but I'm actually going to subtract the data points from the expected value and then take the absolute value of that. So my mistake, when you're inputting the expected values for the data points corresponding to the fit line, you don't need to do the absolute value. But this one we do. So I'm going to do, this is our measured column and this is our expected column. The absolute value of the measured column, so that's K15 minus the expected column N15. We have to make that equal sign. Okay, so now we have a bunch of values for how much it differed from where it should be on the fit line. So now the last thing that you need to do is just take the average of those values, like so. So I'm just going to formulas, insert function, and then to average. So there we go. Our uncertainty is going to be plus or minus 4.68. Our measured value was 944. And we expected it to be 980, so it's a little on the low side, probably because of air drag and such. But this isn't a reasonable value for your uncertainty, and you got that by just taking the absolute value of the measured versus the expected, and you got what the expected value from the trend line. So that's how you're going to want to do it in your lab report. Thank you.